Theoretical recap. The TCP three-way handshake is the mechanism by which two hosts establish a reliable connection before any data is exchanged. It consists of three segments. SYN, client initiates, proposes an initial sequence number, SYN-ACK, server acknowledges and proposes its own ISN, and ACK, client acknowledges the server's ISN. This exchange happens at layer 4 of the OC model, transport, but Wireshark lets you observe it all the way down to the Ethernet frame at layer 2. A key mental model. Think of the handshake as a mutual introduction where both sides agree on conversation I.D. sequence numbers before exchanging a single byte of payload. Common mistakes beginners make include confusing the SYN-ACK with a data packet, missing the handshake because capture was started too late, or failing to apply the right display filter and getting overwhelmed by noise. A quick example. When your browser connects to a web server on port 443, Wireshark will show a frame flagged SYN from your IP to the server, immediately followed by SYN-ACK from the server back to you, then your ACK, closing the ritual. From that point on, TLS negotiation begins on top. This recap builds directly on your previous work with Netcat TCP handshakes and your first steps with Wireshark. Now you combine both. Workshop brief. In this workshop, you will use Wireshark to capture and fully dissect a real TCP three-way handshake. The goal is not just to see the packets, but to understand each field, each flag, and each sequence number involved. You have already established a TCP connection manually with Netcat and explored the Wireshark interface. This workshop is where those two skills converge into a single, meaningful analysis exercise. You will generate real network traffic yourself, capture it, isolate the handshake, and produce a structured written analysis of what you observed. Setting up your capture environment. Before generating any traffic, open Wireshark and select the appropriate network interface, typically your active Ethernet or Wi-Fi adapter. Start a capture session and immediately verify that packets are flowing. If you see nothing, you have selected the wrong interface. Do not generate your test traffic yet. Apply a capture filter if you want to reduce noise from the start, for example, filtering on a specific host or port, but be careful. An overly restrictive capture filter may cause you to miss the handshake entirely if applied incorrectly. Once you are satisfied that Wireshark is capturing live traffic on the right interface, you are ready to generate the handshake. Use a method you are already familiar with, curl to an HTTP endpoint, a browser request, or Netcat targeting a server on a known port such as 80 or 443. A local target, for example, a simple Python HTTP server running on localhost, is a valid and clean option that minimizes noise. Alternatively, connect to a well-known public server. Either approach is acceptable as long as you can isolate the handshake clearly. Isolating and analyzing the handshake. Once you have captured traffic, stop the capture and apply a display filter to isolate the TCP handshake. The filter tcp.flags.syn=1 is a useful starting point, but you should refine it further to target exactly the conversation you generated. Identify the three packets that constitute the handshake: SYN, SYN-ACK, and acknowledgement for each of these three packets. Expand the TCP layer in the Packet Details pane, and carefully note the following fields: source and destination ports, sequence number, acknowledgement number, flag set, window size, and any TCP options present, such as MSS or window scaling. Pay close attention to how the sequence and acknowledgement numbers relate to each other across the three packets. This numerical relationship is the core of what makes TCP reliable. Also note the timing between packets, visible in the time column. If you are connecting to a remote HTTPS server, observe that the handshake completes before any TLS record appears. This confirms the layered model you studied earlier. Deliverable. Written analysis. Your submission must include two elements. First, export the captured handshake as a PKPing file containing at minimum the three handshake packets, and ideally the full conversation for context. Second, write a structured analysis document, plain text, markdown, or PDF, of 300 to 500 words covering the following points: a description of the network context, what traffic you generated, source and destination, ports involved, a field-by-field explanation of each of the three handshake packets, an explanation of how sequence and acknowledgement numbers evolve across the handshake, and at least one observation about what this handshake reveals from a security or reconnaissance perspective, for example, what an attacker could infer from a SYN scan, or what a half-open connection looks like. This last point connects your work directly to the Nmap port scanning you practiced earlier. Think about what Nmap actually sends and receives during a SYN scan and how it relates to what you are now seeing in Wireshark. Be precise, avoid vague statements, and support every claim with data from your capture. Advice and common pitfalls. If your capture is flooded with unrelated traffic, use the Follow TCP stream feature in Wireshark to isolate a single conversation. Right-click on any of your target packets and select this option. If you are capturing on localhost, loopback interface, make sure to select the loopback adapter explicitly. It does not always appear as the default interface. If you are using HTTPS and the payload appears encrypted, which it will, that is expected and correct, your analysis focuses on the TCP handshake layer, not the application data. Do not confuse a TLS client hello, which comes after the ACK, with part of the TCP handshake. If you are struggling to find the 3 packets, sort by the time column and look for the earliest packets in your filtered view. You are allowed to consult all previous course materials, Wireshark's official documentation, RFC 793, the TCP specification, and any internet resource you find useful. You may work alone or ask for peer help, but the written analysis must reflect your own understanding.